Hello everyone, welcome back to another video. So today we will discuss solutions for weekly contest 379, and I will only discuss first three solutions to first three problems. So if you want only the solution of fourth problem, you can just skip the video. So let's start with first problem. So in first problem we are given a vector named as dimensions, and in each position I there is a vector in which dimensions of I of 0 represents length and dimensions of I of 1 represents width of a rectangle, and we have to return the area of a rectangle which is having the longest diagonal. And if there are multiple rectangles, we have to print the one which has maximum area. So let's take this as a rectangle and the length is L and width is W. Now if you know the Pythagoras theorem, this length can is equal to under root of L square plus W square. So we are given this and we need to calculate this and find the maximum value of this, and for all such maximum values which are equal to max of all L square plus W square, we have to take uh, the the area which is maximum. So L into W we have to take for each uh, index where it satisfies that this is maximum. Now you don't need to calculate square root, you can just calculate this sum, because x, if x is greater than y, root of x is also greater than root of y. So we just have to calculate this sum and then iterate again for calculating maximum area. So first of all I'm declaring two variables, answer and d, and I will iterate for all in the vector and calculate the uh, this value L square plus W square and take max of it with d. Now d is storing the maximum value of L square plus W square. Now I will again iterate through the vector, calculate j, and if that d is equal to j, means that the length of diagonal is maximum for ith index, I will take maximum area and store it in answer variable and just return that answer variable. So this was first problem, as usual, very simple. Let's move on to second question. Now this second question had some cases, or you can say we have to write a simple brute force, right? So in this question we are given a three positions of a white rook, a bishop, white bishop, and a black queen, and we are given positions of that in terms of A, B, C, D, E, F. A, B denotes position of white rook, C, D denotes position of white bishop, and E, F denotes position of black queen. Now we have to print minimum number of moves required to capture black queen. Now let's just so this is the 8 by 8 chessboard. If you know, 1, 2, 3. So indexing starts, so this cell is 1 comma 1, this is 1 comma 2 up to 1 comma 8, this is 2 comma 1, this is 2 comma 1, and this is 2 comma 8, similarly 3 comma 1 up to 8 comma 1, and this is 8 comma 8. Now a white rook can move horizontally. So if I press let's consider the position of rook is R. So in one move it can move to all these positions and also all these positions. So these are the rook movements of rook in uh, one move. Now let's take for bishop. Now bishop can move uh, diagonally to any direction in one move. So it can go from here to here at any place, in similarly here to here, on the this also, and on this also. So these are the moves of bishop, and queen is in this problem. Queen is kept at same position, it will not move. Now we have to find the number of moves required to capture queen. To capture queens means to reach at a position, to reach at the square of queen. Now for example, this rook can reach queen in two moves. How? First move it will move to till here, and in second move it will go to queen. So total number of moves required by the for the rook to reach queen are 2. Now let's just see one example. As you can see in first example, the position of rook is this, and position of queen is this, and position of bishop is this. So bishop can move diagonally, so it will move from this diagonal. There is only one diagonal which is possible here, because all other diagonals are moving out of chessboard. So bishop can move on this diagonal only. So from bishop capturing queen is impossible, but from rook it is possible, because rook can move one position down and two position right and will capture the queen. So answer here is 2. Similarly, in second example, bishop can capture this queen via diagonal, or the rook also can capture this queen in just one move. So the answer of this is 1. So most first important observation here is the answer of this, the total number of operations required to capture the queen will always be less than equal to 2, because in whatever position of this queen is there, the rook can capture the queen in at most 2 times, because it can the rook will move to its rook will move to the same column of queen, and then it will move to same row of the queen. So as here, the positions of this rook and queen, as you can see in this picture, so rook can just move here and here. So if you try to find all the positions of rook and queen, you will see that the rook will always capture queen at most 2 operations. So answer for this will be at most 2, either 1 or it will be either 2. Now when it will be 1, so that can be checked with brute force. For example, if this is rook, so it can move all the uh, horizontal squares which are in the same row as the the rook square can be reached in one operation. Similarly, all the squares which are placed above and below the rook square can also be reached in one operation. So we can brute force and check this, because the at most we have to iterate 8 times in each direction, because there are only 8 rows or 8 columns on the chessboard. And similarly we have to check for bishop. Now bishop moves this diagonal, this diagonal, this diagonal, and this diagonal. Now how to check this? Let's say this coordinate of bishop currently is x, y. If it moves towards uh, between up and right, so this, for this, x will increase but y will decrease. If we say that in the direction bottom, between bottom to right, bottom and right, x will also increase and y will also increase. And if we say between left and bottom, x will decrease and y will increase. And if we say between top and left, x will also decrease and y will also decrease. So we can brute force this and check if it is possible to capture the queen in one move. Now there is also one condition, that if if bishop is moving in this diagonal and there is rook between queen and uh, bishop, so it cannot capture this queen in one move. So we also need to check if uh, rook comes before queen, and if it comes, we have to we cannot um, capture queen in one operation. So these are the basic conditions. Now if we see implementation, implementation is very easy, but multiple implementation, multiple for loops or multiple implementations are required. So first of all, I am checking for bishop. So I declare b1 b2 as cd. b1 b2 are basically current coordinates of bishop, and I will keep uh, I will run a while loop until both of them are greater than equal to 1, and if it becomes equal to uh, rook's position before becoming equal to queen, I will break, because there is no possible way, and rook is coming between bishop and queen, so I will break there. Now second, if I reach the if the bishop can reach the queen, I will just return 1, because minimum possible answer is 1, and I will just decrement b1 and b2, so this direction is checked. Similarly, I will do this for all four directions. So as we discussed, this one, this direction, and this direction. Now I will do same for this for rook. Now for rook, I will declare b1 as a, and while b1 greater than 1, I will check if it reaches queen, or if bishop comes before queen, I will just break. So bishop is blocking the movement between rook and queen, and so this is again four directions for a rook, and in any of these cases I am returning no value. I will just return 2, because maximum possible answer for this question can be equal to, is equal to 2, so I will just return 2 at the end. So yeah, now third question. So it is, I think, normal C, because probably easier than most third problems. So in this question we are given two arrays, nums1 and nums2, and we can remove n by 2 elements from nums1 and n by 2 elements from nums1 and nums2, and after the removals we have to insert all the remaining elements into S, and such that the S forms a possible size, the size possible is maximum, so we have to return that maximum size which is possible by performing the given operation. So for example here 1 2 1 2 and 1 1 1 1, so we will remove 1 2 1 2 from first array and 1 1 from second array, and if we insert them into set, the number of unique elements are equal to 1, and number of unique elements are, the unique elements are 1 and 2, so total set size is 2. Similarly, in second case, if I insert 4 5 6 from first array and 2 3 2 from second array, we will get unique elements as 2 3 4 5 6. So the count of such unique elements is 5, so set size will be 5 and answer is 5. Similarly in this, if I insert 1 2 3 from first array and 4 5 6 from second array, total number of 6 unique elements are uh, inserted in the set, so answer here is 6. So and we are also given n is even, so n by 2 we don't have to consider like floor or seal. N is even, so n by 2. Now let's say I have this array A and this array B. I have 1 2 3 4 5 and again 1 2 3, so n should be even, so 1 2 3 4 5 6 and 7 8 9. Whenever we insert an element from this nums1, our counter decreases. Means we can only insert n by 2 elements. So if I insert one element, the counter decreases by n by 1. So here I have also taken, let's say counter here is n by 2. So n by 2 means counter is basically number of elements, which we can insert. Now if you try to find in most optimal insertion, most optimal insertion is when we insert an element which is present in A but not present in B. For example, if we insert this 6, we don't have any kind of loss, because if we insert 6, this counter will decrease. The counter will decrease after each operation, but the possibility of unique elements in the set increases. Now if I would have pushed this 3, let's say instead of inserting 6 I would have inserted 3, and again I would have inserted 2, again inserted 1, and now this elements I can insert, but I don't have a generalized formula that this will work, generalized proof that this will always work. But if I insert an unique element which is present in only A but not present in B, I would have a proof that there is no waste of this counter. So I will first insert this element, first insert all the elements which are present in only A but not B. So I will insert 6 5 4, and after inserting I will just decrement the counter at each. Now I was able to find 3 elements, so counter will just become 0 because n by 2 is here is 3. Then again from B I will insert all the elements which are present in B but not in A. So 9 8 7. So here counter becomes 0. So the set size becomes 6. Let me just take another example in which you can understand. Okay, I'll take the sample test 2. 1 2 3 4. Now if you see here, I have to insert, if I insert this element first, according to our previous formula, we have to just insert all the elements which are present in A but not in B. So we inserted 6 5 4, and then so this counter becomes 0. Now we cannot insert any element from this uh, array. Now we will check if there are possible elements in B which are present in only B but not in A. So there are uh, no possible elements here because 2 is present in this uh, array A and 3 is also present in array first array. But the counter, we can still insert more elements. So I will iterate in both the vectors, and if the the element is not present in final set, I will insert that. If the counter is positive, here counter is 0, so I can't insert any element from this vector, but I can insert from this vector. So I will come to first I will check for 2. 2 is present in final set, no, I will insert 2. 3 is present in final set, no, I will insert 3. Now again 2 is already inserted, so we can't we don't have to insert it. 3 again, no, no, no. Here counter is 1, but there is no possible way that the set size increases. So here answer is 5. Similarly, let's take the third test case also. So 1 1 2 2 3 3 and 4 4 5 5. So this is first vector and this is second vector. Now so first we will all insert all the elements which are present in uh, first array but not in second. So this 3. Now I cannot insert this 3 because I have already inserted 3 in final set. So I will insert 3 first, then 2, and then 1. This will not be inserted, and counter will become 0 because n by 2 elements are already satisfied. So 3 2 1. Now from this I will insert 6, not this 6, 5, not this 5, 4, not this 4. So 6 5 4. So the set size becomes 6 and counter also becomes 0 because there is no counter, we cannot insert other elements. Now let me just take more generalized example. I cannot, so let's say 1 2 3 3 5 and 4 and 7 8. Now in this case, if you see, I will insert this 4, I can insert this 5, and I can also insert this 3. So in first test is 4 5 4 3, because the occurrence of this element in second is again 0, so I can element all the unique elements first, and again I will insert these unique elements. So yeah, this is the solution. So we have to find a optimal strategy of insertion. So that optimal strategy is to first pick unique elements from A which are present in only A but not B, and at most n by 2 elements only. Similarly, pick unique elements which are present in B but not in A, and at most n by 2. And if this counter, the if let's say if I insert n by 2 minus 1 element, so I can I insert any one element from A. So I will try to insert such element which is not present in final set. So we can increase this size of final set, and this is the optimal strategy. And I just implementation is very simple. So I declared two set and inserted all the first in first set I inserted all the elements of A, and in second set I inserted all the elements of B. Now I have declared the counter for first array at 0 and a final set. Now for I will iterate for all the elements in first set, and if I cannot find the set in set 2, I will insert it into C and increment the counter. And if that counter becomes equal to n by 2, I will break. Similarly, I have declared another counter, and for second counter for storing how many elements I have inserted from second array. So if I cannot find that element in first set, I will insert that element and increment the counter, and if counter becomes equal to n by 2, I will just break. And now I will until the counter becomes n by 2, I will iterate and I will try to insert elements which are not already in set and increment the counter if I find any element. Similarly, for I will do this for B array, and finally just return the size of final set. So this was third question, and I was unable to solve fourth question, so I will not make editorial for it. I think it was slightly tougher than usual fourth problem. Only 72 people were able to solve it. So yeah, that's it from my side. Thank you for watching.